1, 2, 1, 2, 1, 2. I hope the problem is solved. I hope you guys can hear me loud and clear now. Okay, I think it should be okay now. So I'll just go over what I've been saying again, just to allow you at least to be able to follow. So briefly, what we've said in this case, we have explained quantities. That quantities are classified into vectors and scalars, and with scalars it's very simple. Scalar quantities like mass, time. When you have got 3 kgs and 4 kgs, you simply add the masses algebraically to get 7. But with vector addition, because of the sense of direction, when you add 3 and 4, at times we do get 5 because of the orientation of the vectors. So in this case, if the vectors are such that they are components of a certain vector, or they're acting perpendicular to each other, so that you are having a displacement from O to P, then one from P to Q perpendicular to the initial, then the overall displacement will be from O to Q, which is represented by C. And if we add vector A plus vector B, which is 3 meters east, 4 meters north, the resultant is 5 meters northeast. Right? So the vector there, vector C, is 5 in magnitude, but the magnitudes of vectors A and B will be 3 and 4 respectively, such that we are adding vector A, which is 3 meters in magnitude, and vector B, which is 4 meters in magnitude, and the magnitude of the resultant vector C is 5. But the directions are quite important in this case, because this is 3 meters east, this is 4 meters north, and the resultant is 5 meters northeast, like that, if we were to describe the vector fully in terms of magnitude and direction. So what I also went on to explain the notation that we now are given a vector A, and it is presented as A theta in square brackets. Then this A theta means it's a magnitude of the vector A is basically A. In this case, you see the notation there. A is not in bold. It is just representing a magnitude, a value, or a number. And theta is the angle. So this magnitude is the magnitude of the vector cos theta in the I. So this is the x component, plus the magnitude of the vector A sine theta in the j. So these are the two components of the vector which I've shown here. One component in the x and the other component in the y. And if theta is the angle between the vector and the component, then that component is the cos theta component. Meaning, you know that cos theta is opposite over adjacent. So the adjacent vector, in this case, this is the adjacent. The adjacent vector is always the cos theta component. And the opposite vector will always be the sine theta component. So in this case, we know that a cos theta will be in the x, a sine theta will be in the y, because theta is the angle subtended by the cos theta component and the vector. But if we change and our angle is phi, this is phi, different from theta, which means the angle that adds to theta to give 90 degrees. Then the adjacent now changes. The adjacent is now the vertical. So a cos phi in the j is now the cos theta component, because it is subtending the cos phi, it's now the cos phi component because it is subtending the angle phi with the vector, right? So you have a cos phi in the j, and because phi is 90 minus theta, cos phi is equal to sine theta. So this cos phi and sine theta are equivalent. So the same would apply. The opposite one will be a sine phi. A sine phi in the j. So that's basically what we said about the introduction to the use of vectors in calculating the magnitudes and directions, or the resultant vectors in different cases. So what we're given in the question number 11 that's showing on the screen, are vectors A and B, which are such that a vector C is equal to 2A minus B. So we multiplied the magnitudes of vector A by 2, and we got 24 for the ith component and 32 for the j component, and subtracted the vector B, which is minus 24i plus 10j. So taking the components, like components together, 24i plus 48 plus 24i gives us 48i, and minus 32j minus 10j gives us minus 42j. And to get the magnitude of the resultant there, we then use the Pythagoras theorem to get the magnitude of this resultant vector. So squaring 48 and adding it with the square of 42, then taking the square root, gives us that magnitude. So that's the root of 48 squared plus 42 squared. So the negative 42 squared is same as 42 squared. That gives us 63.8. 63.8 for magnitude. So that magnitude there, 63.8, is approximately equal to 64. So we'll take 64 for our magnitude. There are no units there, so we'll just stick to that. And that's 64. So that's basically how you get to the magnitude of the resultant vector. You add the vectors first, then you take the root of the sum of the squares of the added vectors, of the components in the I and in the j. So we have a similar question here, where we want the magnitude of A minus B. So we'll simply do the same thing again. We'll do the same thing. So we are given again the notation, but vector A is 1580 degrees, and vector B is equal to 12i minus 16j. So what is A minus B? So we know that this means we have 15 cos 80 plus 15, that's in the I, plus 15 sine 80j. These are the two components for vector A. And therefore, A minus B, magnitude of A minus B, you can write it like that, is equal to, or let's find A minus B first. Let's say A minus B before we go to the magnitude. So that A minus B will be 15 cos 80. Let me enumerate that. (15 cos 80) is 2.604. So we use 2.6 in the I, plus 15 sine 80, 14.8 plus 14.8j, then minus B, B is 12i minus 16j. So remember to put a bracket for the whole vector B, so that the negative does not only affect this ith component, but it affects both the I and j. So taking the magnitudes that are both in the ith component, we've got 2.6i minus 12i. That should give us 9.4i negative. Then 14 minus 16 is plus 30.8j. Okay, so this is vector A minus vector B in vector form, and the magnitude of this vector will be the square root of negative 9.4 all squared plus 30.8 all squared. Just like that. Just like that. Negative 9.4 all squared minus 30.8 all squared. I'm getting 29.3 for this magnitude. I'm getting 29.3. Did I calculate it right? Okay. It's actually 32.2, sorry. It's actually 32.2. It's actually 32.2, which is this 32 here. Okay, so everything else is okay. It's just I'd punched something on my calculator the wrong way. But that gives you 32.2 for the magnitude, which is simply rounded to two significant figures as 32. So can you attempt this one? Can you attempt the third one? The magnitude of the sum of the two vectors given the question shown. The quality of this, okay, Kamvelihle, are you having troubles with the video? Or is it the screen? Is it the screen? I don't have better lighting for the screen. I don't know how best. Let's see. There's no way that will improve. Let me just check if there is something I can do with the resolution. Okay, I think we are good to go. Sorry about that. I'm sure most of you who have challenges seeing it's really quite faint, yeah. So if you are using your phone or some other device, still I know you'd have struggles to see this. But anyway, I've just tried to pick something different. I hope it doesn't really make much difference though. So a vector A is denoted by magnitude 10 meters. Now we have units and 30 degrees to the horizontal. And another vector D, which is so we also have vector D, which is a magnitude of 25 meters at an angle of 130 degrees to the horizontal. So you can already see the picture there. If we try and draw the two vectors, let's say we have a Cartesian there, then vector A is only 10 meters at 30 degrees. This is the 30 degrees there, and that's 10 meters. Then the other one is 25 meters, but at 130, so you know this is 90, 130 will be in that quadrant. So you have 25 meters, and the angle there is 130. So this is vector A, this is vector D. Now, what is the magnitude of the sum of these two vectors? So the magnitude of the sum of these two vectors, if we look at them graphically, so I'm just doing this, it's not really necessary if you understand what you're doing. You would just go on straight to the working and you get your answer. So here we have the resultant, and we want the magnitude of this resultant. In other words, already you can see the angle there is greater than 90. It's greater than 90 degrees for the resultant. That's what I just wanted you to show you there. But anyway, for us to get the resultant, we know that A is equal to 10 cos 30 I plus 10 sine 30 J, and D is 25 cos 130 I plus 25 cos 130 J, I and J. Okay. Okay. So for us to find the magnitude of the sum, we first add A and D. So the sum will be vector A plus vector D, and that will be 10 cos 30 plus 25 cos 130. which is negative 7.41 in the I. Then we add 25 sine 30. So sorry, this is supposed to be sine 130. 25 sine 130 cosine sine. So we add 10 sine 30 plus 25 sine 130. This gives us plus 24.15J. So these are the two components for the sum of the vectors. Right, so the magnitude therefore will be equal to the square root of minus 7.41 squared plus 24.15 squared. That would be for the magnitude. That gives us a magnitude of 25.2 meters. The magnitude is 25.2 meters. Which is rounded to two significant figures, that's 25 meters. Which is okay. Okay. So the next question is question number 14, which is also a simple one. And the question reads, the diagram below shows the path taken by a sailboat tacking sideways because it cannot sail directly into the wind. Use this exhibit to answer the following questions. So referring to exhibit 3.4, which is the diagram that you have just seen, the total displacement of the sailboat, which is the vector sum of its displacements, OB, which is 2000 meters, BC not given, CD not given, and DE not given, is, so how do we get the total displacement from O to E? OB plus BC plus CD plus DE. How do we get the total displacement? Anyone? So what we do there, remember displacement is the shortest distance between 2 points. So what is the shortest distance between O and E? Excuse me. So that total displacement is simply, you have that diagram. So we are told that displacement from O, we have B, then B to C, C to D, and D finally to E. And this is the east. And definitely north. And this, we're told that point is 1732 meters. And this one is 6298. So remember, O to B, B to C, or in other words, OE equals to the vector sum of OB plus BC plus CD plus DE. But the vector sum for the displacement in this case, OB to BC, is simply that same distance. Then CD to DE will also be that distance, and the sum of those distances, the displacement is simply 6298. We don't need to calculate anything. We just have to know what is displacement and look at the given figure, then pick the appropriate answer. So there's nothing to really calculate there, rather than pick that displacement is a magnitude of 6298 meters in one direction, which is the easterly direction. So nothing to really calculate there. The answer is already there and given. And the last part, last question for the day is similar to the previous one, to question number 13, where we have a vector A and a vector D. A is 10 meters to the horizontal, is a displacement 10 meters to the horizontal. D is a displacement 25 meters at 130 degrees to the horizontal or to the east. So the direction of the sum of these two vectors already is the direction of R. And in this case, we have the components of this resultant as the sum. Already, remember, we had got these values, negative 7.41, negative 7.41, and 24.15. So the negative 7.41 is a displacement in that direction. And the 24.15 is a displacement in the positive y. So the resultant there is that one at an angle phi, such that phi, tan phi, is equal to opposite over adjacent 24.15 over 7.41. So we find this phi, we use the value of phi to find theta, right? So phi will be arctan actually there's a negative there. So arctan 24.15 over negative 7.41. That's negative 72.9. arctan negative 3.26, which gives phi equals to 72.9 degrees, such that theta is equal to 180 minus 72.9 degrees. That gives you 252.9, which is 253. Sorry. 180 minus that is 107. Sorry. It's actually 107 degrees. So the theta there is 107 degrees. The angle theta is just greater than 90, so it will be 107 degrees. That angle is 107 degrees. So we find phi, which is the angle. Remember the ith component in the I, the component is minus 7.41, so the vector is in the negative direction. The j component is positive 24.15. The resultant is in between the two. So the angle phi is arctan the y component over the x component, which gives us 72.9, but theta is 180 minus 72.9. That's why we got theta is 1.107, because the angle has to be measured from the 0 degrees, which is the first quadrant. So that's how we get the answer to that part of the question. So don't fall for the 73 there. It doesn't give you a correct angle. The correct direction is 107 degrees. So I think that's all for today. In the next session, I'm sure we have sorted the issues with the working screen so that you get better resolution for the board from where we do our working. But otherwise, from me and the Yabo Physics team, thank you for joining us. If you have any questions whatsoever relating to this and other things that have already been covered, please feel free to reach out to us. Otherwise, you have a good day and all the best with your studies. Bye-bye.